Alright, we're back with a math lesson. Today I'm going to go over 3.4, which looks like this. Right, solving quadratic equations by factoring. Then we're also going to go over 3.5 because these are both fairly short lessons. And 3.5 is nothing new. It's just solving problems, choosing a method. So we're going to review how to find the roots of an equation using either a table of values, factoring, or graphing. Right, I'll put both these sheets online with the website, and then you have your textbook homework and this worksheet in your package. It's titled 3.4, Solving Equations by Factoring. Okay, but if you want to solve by trying to do a table of values or graphing, go right ahead. You can use Desmos to help you graph if you need to. Alright, so let's go straight to solving equations by factoring. Alright, example number 1 really isn't too hard. You don't even have to factor. But given this equation, x plus 3 equals 7, it says find the solution for each. Well, rearranging the equation, bring the 3 to the other side by subtracting it from both sides, and you get x equals 7 minus 3, so x equals 4. Right? That's not too bad. Good review. Part B says 2x squared minus 7 equals 11. Same thing. Bring the 7 to the other side using the opposite operation. So we're going to add it to both sides. So you get 2x squared equal to 11 plus 7, which is 18. Divide both sides by 2 to get rid of that 2. Again, it's the opposite operation. If you have x multiplied by 2, the opposite would be to divide by 2 and do it to both sides. You get x squared equals to 18. Then again, the opposite of a square is a square root. But when you take the square root, you actually have two solutions. Okay. Oh, that shouldn't be 18. I divided it by 2, so it should be 9. And the square root of 9 is 3. But taking the square root gives you two solutions, plus or minus 3. Well, why is that? Well, plus 3 squared would give you 9, but also minus 3 squared gives you 9 as well. Minus 3 times minus 3, 2 negatives gives you a positive. And that's actually part A in example 2. So let's get to part B in example 2. Okay, part B, we have more of a trinomial quadratic here. X squared plus 7x minus 25 equals 5. Alright, so first we can bring this 5 over to this side, subtract it from both sides. We get x squared plus 7x minus 30 equals 0. Now we can factor. This is a simple trinomial because our a term is 1, so we don't need to use decomposition. All we need to do is ask ourselves, what two numbers multiply to give you minus 30 and add to give you positive 7? Okay, so if you had negative 10 and positive 3, right, those give you minus 30, but they add to give you negative 7. So let's try the opposite, positive 10 and negative 3. Again, they multiply to give you negative 30, but in this time you have 10 minus 3, they add to give you plus 7. So we put our x's there. Right? And then to find a solution, this bracket could equal 0, or this bracket could equal 0. To make this bracket 0, we have x minus 3 equals 0. Solving for x, bring minus 3 to the other side, x equals 3. For this bracket to equal 0, we have x plus 10 could equal 0. Solving for x, x equals negative 10. So here are your two solutions, 3 and negative 10. Okay. All right. Hopefully you noticed something different in the video quality. If it's better, let me know. If it's worse, let me know. But I've got a new web camera and I'm using a new software to do this. All right, so we'll see how it goes. Example 3 says find the roots of each. That's the same thing as finding the solution. Okay. Part A. We have x squared minus 5x plus 6 equals 0. All right, again, we have a simple trinomial. Right, so we need to find two numbers that multiply to give positive 6 and add to give you minus 5. Right, so negative 6 and plus 1 work. Right? They multiply to give you hold on. You need to get positive 6. Those are not going to work. 3 and 2 should work. Let's try 3 and 2. Right? They multiply to give you positive 6, but they don't add to give you negative 5. But if we make them both negative, then that works. So x, there we go. Right? So our solutions then would be when this bracket equals 0, that would give us one solution, and the other would be when that bracket gives you 0. So here we have x minus 3 can be 0. Solving, you can get x equals positive 3. Or over here, x minus 2 would equal 0, and solving gives you x equal 2. So those are your two roots, your two solutions, your two x-intercepts, whatever you want to call them, all the same thing. Okay? All right. Next, part B. We have 2m squared equals 3 minus 5m. Okay, now this is a tricky trinomial because we have this a term not as 1. But first, let's bring everything to one side of the equation and set it equal to 0. So we have 2m squared. Bring this to the other side, it's minus 5m. So you add it to both sides to get plus 5m. Positive 3 becomes negative 3 equals 0. Alright, so here's our tricky trinomial. You can use the x method, you could use decomposition, or since you're just solving for the roots, you could also use the quadratic equation. Okay, now in class, lots of people seem to like decomposition, so I'll continue to do that. So first, take your a and c term, 2 and negative 3, multiply them together, you get minus 6. And then think of two numbers that multiply to give you minus 6 and add to give you plus 5. What are those two numbers? Well, we're going to have minus 3 and minus 2. Do those work? Well, minus 3 times minus 2 give us a positive value, so they don't multiply to give you negative 6. All right, let's try positive 6 and negative 1. Do those work? Well, positive and negative will give us a negative, and 6 minus 1 gives us plus 5, so check. That works. Now what we're going to do is we're going to split up plus 5 into plus 6 and minus 1. So we have 2m squared plus 6m minus m. If you want to write minus 1m, that's fine, but you don't need the 1. Minus 3 equals 0. Now, factor by grouping. So let's take one group here, and the other group here. First group, pull out a common factor. It's going to be 2m multiplied by 2m times what gives you 2m squared, which is m. And 2m times what gives you 6m, so plus 3. Now over here, I'm going to pull out a -1, and I do that because I want to get the exact same bracket here. I don't want it minus m minus 3. So pull out a -1, and you'll have a bracket of m plus 3. Okay, then we have this bracket, m plus 3. That's our new common factor. And we're going to multiply that by what we have left over, 2m minus 1. All right, now for this to be true, m plus 3 could be 0. And solving for m, one possible solution is m equals minus 3. The other one is this, 2m minus 1 can be 0. Solving, we get 2m equals 1, or m equals 1/2. Okay, so those are our two solutions. M can be -3, or m can be in half. Those are x-intercept solutions, roots, again, whatever you want to call them. All right, it says for part C, determine whether the given number is a root of the quadratic equation. So part C says, is x equals 7 a root of 42 equals x squared minus x? Let's look at this one. All right, so if you want to see if it works, let's first write this as a quadratic. So 42 equals x squared minus x. So bring 42 to the other side. By subtracting it from both sides, you get 0 equals x squared minus x minus 42. Now to see if 7 is a root, what I can do, I have, well, two ways. I could just find what both roots are and see if 7 is one of them. Or I can substitute 7 into x and see if this side of the equation does become 0. If it does, it's a root. If it doesn't, it's not. So let's try that. So just going to look at this side. Let me just write right side equals 7 squared minus 7 minus 42. So 7 squared is 49. 49 minus 7 minus 42. 49 minus 7 is 42. And then 42 minus 42 is 0. So left side equals right side. 0 equals 0. So yes. Yes. 7 is a solution or a root to that quadratic equation. All right. Now that's it for 3.4. The worksheet pretty much is based off of this, but I do also want to go over 3.5. Okay, 3.5 says we can solve a quadratic equation, meaning find the root, solution, x-intercepts. Okay, whatever I asked for on any assignment, whether it's roots or solutions or x-intercepts, you're finding the same thing. Right? And this can help find us the vertex, the min and max points. Then we can solve the quadratics by factoring or graphing or using a table of values. So 3 ways to do it. Now they give us an example. It's a function p of x equals minus 2x squared plus 32x minus 110. And it's asking us to find the solutions using 2 different methods. Okay. Sorry, 3 different methods. First one is table of values. So they give us x and minus 2x squared plus 32x minus 110. And then you have all these different values for x. 1, 2, 3, 4, and so on. And all you're doing in this case is substituting that x value into that equation. So if you plug in 0, that whole term 0, that whole term 0, and you're left with minus 110. If you plug in 1, well, you can try this. Make sure you get the same answer as I do. I got minus 80. And I'll post these if you plug in 2, minus 54. If you plug in 3, minus 32. And so on, minus 14. And then I got a 0 at 5. So that means 5 is a solution. X equals 5 is a solution. And you can keep going down to find what the other solution is as well. The second option is factoring. I should have just left that equation there. Alright, so we have p of x equals minus 2x squared plus 32x minus 110. Now, first it might look like a tricky trinomial, and you might want to go straight to decomposition, but remember to always look for a common factor first. And every single coefficient is an even number. So I can pull out a 2. In fact, I'm going to pull out a negative 2. So negative 2 all times by x squared minus 16x plus 55. Minus 2, and then we need to solve this simple trinomial. Two numbers that multiply to give you 55 and add to give you minus 16. Now they're bigger numbers, but there's a kind of a hint in what we've already started with the table values. We know that x equals 5 is a solution, so I can write x minus 5. So I know one of them is 5. 5 times what gives you 55? Well, negative 11. Do those numbers add to minus 16? Yeah, minus 5 plus minus 11 give you minus 16. Right, so x can be 5, but looking at this bracket, x can also be 11. And if you continue down in your first method, down your table of values, once you got to x equals 11, you would get 0 as well. Right, so that's factoring. The last example is by graphing. And you can use Desmos to graph, but you don't have to, because the graph is actually on the next page, right there. Okay, so there's the graph. Just hold it there. And you'd have a solution right there, right? Remember, it's your x-intercepts. So let me just mark them here and here. Those are where your solutions are. And you can see, well, it's a bit fuzzy, but on your page you can see that it's 5 and 11. Right? On the graph you can also see that max point as well. You can get the max point from the table of values as well. You can get it from the graph. From the equation, you'd have to first find the axis of symmetry, which we've done in previous lessons. Right? Add 11 and 5. 16 divide by 2, that's 8. So you know the vertex is at the x-coordinate 8, which you can see right on your graph, the x-coordinate of 8. And then you can substitute 8 into x to see what the function equals at 8, to figure out what the y-coordinate is. Okay, now this says which method is better. Well, one really isn't better than the other. Certainly factoring is my go-to one, because you always get an exact number. Factoring can be difficult if your solutions are things like 10.87 and 9.23. In that case, instead of factoring, you might want to jump to the quadratic equation. Okay, graphing is great if you have technology, but again, graphing is going to be difficult without the technology. If you don't have the technology, you're going to be factoring first or using the quadratic equation in order to graph. Right? So you'll be doing method 2 in order to do method 3 in that case, unless you're using Desmos or a graphing calculator. Method 1, table of values, is also a great method, but it can be tedious. And if an answer is something like 9.4, you might not quite get there. You might realize it's somewhere between 9 and 10, but it would be a little bit harder and take a lot longer to try and solve that way. Right? But those are your 3 different methods. Add it to your tool belt, and you can use them at any time. Okay, so that's it for today's lesson. Hopefully the video quality is better. This is your worksheet, which says 3.4, solving quadratic equations by factoring, and then you'll be doing the textbook homework from these lessons 3.4 and 3.5. Okay, I'm not going to post a new video tomorrow because that's a lot of work, but I will post the solutions to the worksheet. And then on Monday, I'll post our last video for this chapter on 3.6. Okay, and then maybe we'll do a little review lesson. It would help if you left me comments to actually tell me what you would like me to review. Because again, our review lesson is not live. So I won't know what you need help with unless you start telling me. Please review this, please review that. So please do that before I post a review lesson next Tuesday or Wednesday. And then I'll do another Google form towards the end of next week where all the questions will be based on your assignment. Okay, the assignment you can download from this stream page. It's the Chapter 3 assignment. So do that, and then I will post questions all from that assignment so that you can just click the ones you got. All right?